So I did a test um, because my interest was piqued the other day when I was looking at some footage that I shot with the FS5 and was comparing the 4K to 1080p and noticed that there wasn't much of a difference. And then I learned about downsampling. So basically, a camera downsamples from a 4K sensor that has 4K pixels on it or more, um, but it downsamples from the full size of that sensor. If you're shooting at 4K, it'll downsample from a 4K dimension to 1080p, and that allows for a few benefits such as some noise reduction, maybe also smaller file sizes, etc., etc. So I decided that I would do a test here, and my own test with the Fuji XT-3, and shoot some 4K footage and downsampled it to 1080p, and then also shoot some 1080p in camera, and then compare all the different types of clips. So I compared the 4K downsampled to 1080p to the native in-camera 1080p, and then I also compared 4K downsampled 1080p to in-camera 4K, and here are the results. So before we look at the comparisons, there's a few things we need to get out of the way. For starters, we should note that this is an HLG clip, and the content was delivered to YouTube at 1080p. So what you're seeing is a 1080p image, whether or not it was shot in 4K or whatever. So that in and of itself is a conversion process. So basically what you're seeing is at least two levels of compression, and in some cases 3 levels of compression. The first level of compression is when the camera captures the image and compresses it to your SD card. The second level of compression occurs when you export your footage from your video editor for final delivery to YouTube. And in this case, there's a third level of compression, albeit it's a very light level of compression, when I downsampled the compressed 4K footage to 1080p. I did use a high-level codec, which is DNx HD, for that conversion, and you'd be hard-pressed to notice the difference between the non-transcoded and transcoded formats. I mean, they're virtually identical. So that third level of compression during downsampling could almost be disregarded. So in this first test, I compare the 4K downsampled to 1080p to the native in-camera 1080p. And what I'm seeing is there's a slight advantage to the downsampled 4K. It's slight to my eyes, and you may not see it on YouTube because of that compression that YouTube does. But to my eyes, I'm seeing a sharper image with the 4K downsampled. I'm also seeing less color noise with the 4K downsampled. But in general, the 4K downsampled is pretty comparable to the 1080p shot in camera. Nonetheless, on my screen, I prefer the image on the left, which is the 4K downsampled. These images were lightly graded to adjust for levels, but other than that, they are the same out of camera. They weren't scaled, and there was no noise reduction or other adjustments made to this footage in post. This next test compares the 4K downsampled to 1080p with the in-camera 4K. And I am very impressed with the downsampled footage. It is almost as good as the 4K image that I'm seeing on my screen. The noise appears to be slightly larger grained in the downsampled image than in the 4K image. But however, I think that the downsampled 1080 has a very slight sharpness improvement over the 4K, but that may just be due to the resampling. I think anybody would be hard-pressed to tell the difference between the 4K downsampled to 1080 footage and the native in-camera 4K footage. I hope you find this information useful and are able to incorporate it into your workflow.